All right, welcome to week 9, the ACT Math Prep course. We're going to start out with some probability and statistics. So we're going to start out with some central tendencies. That's a big fancy word for mean, median, and mode. So we're going to start off with the mean, okay? You probably all know this, but the mean is the average of n numbers. We say n is the number of those numbers. So it could be the average of 10 numbers. In that case, n would be 10. Could be the average of 20 numbers. In that case, n would be 100. So n is the number of numbers that we're averaging, okay? So the formula is pretty simple. The mean is just the sum of the n numbers combined, right? So you add them all together. So you add them up, so you find the sum of the n numbers, and then you divide by the number of numbers that you just added up. So quick example, 3, 7, and 10, and 12, okay? If I want to find the average of those four numbers, the mean, I add them all up, so 3 plus 7 plus 10 plus 12, and then I divide by 4. So we have 10, 20, 32 divided by 4 is 8. So 8 is our average. Now there's something really, really important I need to kind of make sure you understand. Think of it like a balance beam or like a seesaw, right? And you want to balance that seesaw. The median, the average will always, the mean, the average, will always be in the middle of this seesaw. So this number right here will always be your mean, okay? So where do these numbers sit? Well, we know our mean was 8. So 8 would go, this would, like if you think about it like a number line, 8 is right in the middle there, okay? So we have a 3, which is way down here, a 7, which is pretty close, a 10, which is kind of close, and a 12, which is also kind of close. And you see how that averages out to be 8. So if you notice, how far away is the 7? The 7 is 1 below. So I'm going to use a different color here so you can see. The 7 is 1 less than the 8, right? The 3 is 5 less than the average of 8. 10 is 2 bigger, and 12 is 4 bigger. So if you look at the number of numbers, each number is below kind of cumulated. So if you add them all together, this is a total of 6 numbers below the average. And if you look at these, there's a total number of 6 above the average. So that distance from the average to each number is really important to understand, because you can find the mean sometimes faster if you can think of it this way. And there's times where that will come into play, okay? So really understanding that is really important. So there is a relationship. If you look at this, if you look at this equation here, if I multiplied both sides by n, okay, I multiplied this side by n and I multiplied this side by n, see how the n's would cancel? What that leaves me with is the sum of the n numbers is equal to n times the mean. So this is kind of an alternate way of thinking about it. The sum of the n numbers is just the mean, the average, times n. So in our case, right, we had the number of numbers was 4 times the average of 8 made 32, the sum of those numbers. So if you're given the mean and you're given the number of numbers, you can find the sum pretty quickly. Just multiply those two things together. Okay, it's kind of an alternate form of that equation. Okay, so if you know the sum, right, divide by n to find the mean. Pretty basic, right? If you know the sum, you just divide by the number of numbers to find the mean. All right, if you know the mean, okay, multiply by n to find the average. Okay, and again, that's just saying that n times the mean is equal to the sum. So if you're looking for the sum and you know the mean, just multiply by the number of numbers. Okay, pretty straightforward. Now there are questions where they don't give you a number, so you're missing a number. All right, so let's look at a problem. Let's say you know that the average of 3 numbers is 10. Okay, you know the first number is a 12, the second number is a 9. You want to know the third number. Okay, so a couple ways you could do this. You could set up an equation. We know that the mean is the sum of the 3 numbers, so we could say that it's 12 plus 9 plus our third number, which we don't know, divided by 3. Then you plug in what you know. Well, we know that M is actually equal to 10. That's the average. It says the average is 10 in the problem. Then we just solve for X. So how do you solve for X? Well, you multiply both sides by 3, okay, to get rid of the 3 in the bottom there. That leaves us with 30 equals 12 plus 9 is 21 plus X. We solve for X, we realize that X has to be 9. Okay, so you can set up that equation and then solve that equation. That's one way to do it. Okay, alternately, what you could do is kind of use this balance beam technique. All right, we know the average is 10. So the middle of this number line here is 10. I've got a 12, which is up here, and I've got a 9, which is down here, but pretty close to 10. So you can see it's kind of balancing over to the right. It's going to tilt to the right. So we need to balance it. It's going to be a number smaller than 10 for sure. So just think about it, right? This is 2 numbers above the average. That 12 is 2 places above the average. That 9 is only 1 below. So to average that out, to make a 0, I need 1 number below to be added into that data set to make it kind of balance out. So I know that 9 is 1 number less than 10. And if I add another 9 in there, there's my other -1. And now I have kind of a balanced around 10. So that makes 9 the number that needs to be added. So there's another way. Of course, you could guess and check. Guessing and checking kind of can take a little bit of time, but again, it's a strategy that can be useful. So you can still use it. All right, moving on. So weighted average. Okay, I've only seen this a few times in practice tests, but it's worth mentioning. Let's say that you 90% of your chemistry final grade is tests. Okay, 90% of your chemistry grade is tests. All right, and let's say 10% is homework. So if you got a 68% on a test and you got a 99% on your homework, the question is, what is your grade in that class? Okay, so the way that you do this is the average is always the score times the weight plus the score times the weight, and you just continue this on and on and on. So the score, you got a 68 on your test, okay, times the weight, 90%. Now don't use the 90%, convert it to a decimal, so 0.90. Plus, you got a 99 times the weight, which is 10%, so 0.10. So you would just use your calculator to find that answer, okay? All right, moving on. Next central tendency we're going to talk about is the median. All right, I always think about the median. Where's the median when you're driving down the road? The median is the middle. So basically, it's the middle number of a data set. All right. Now, one thing you have to do is you have to put the numbers in order first. Okay. If you don't put the numbers in order, you're not going to get the right median. So first thing you have to do is put the numbers in order, and then you can find the middle. So it's pretty easy when there's 3 numbers, like 3, 6, 10. Those are in order. When there's 3 numbers, or if there's 5 numbers, if I do a couple more, when there's an odd number, the middle number is pretty easy to find, right? It's the number that's in the middle. So what you kind of do is you kind of start crossing out 2 to the left, 2 to the right, until you narrow in on the middle. Now, what if you had an even number of numbers, okay? Well, you start kind of crossing out from the outside in to find the middle. That's sort of the strategy here. When you get to the middle, you realize there's 2 numbers in the middle. Well, all you do is find the average. So remember, average is add the 2, divide by 2. You get 11/2 or 5.5, right? 5.5 is the middle of 5 and 6, right? It's half above and half below. So that's how you find the median. It's pretty straightforward. Just remember to put them in order first. That's the only thing that people get tripped up on, is put the numbers in order before you find the median. All right, so the next thing we're going to talk about is the mode. Okay, so the mode is the number that appears the most. Number that appears the most. It's usually pretty easy to find. Okay, when you're looking at a data set, whatever number is occurring the most, that's the mode. Okay, now, if all the numbers are the same, meaning there's not any repetition, there's not like 2 2s or 2 7s or 2 9s or 3 10s, there's no repetition. All the numbers are the same, What that means is there is no mode. It's not like they all get to be the mode. Every number appears once, they're all the mode. It's not how it works. If all the numbers are the same, then we say there just isn't a mode. That happens sometimes, okay? Now, if there is a tie, meaning if there are two numbers, if there's a tie, so if like you have 3, 3, 6, 7, 7, 10, 12, right? You see how the 3 appears twice and the 7 appears twice? They're both going to be the mode, okay? So this is called bimodal. There can be more than one mode, and just be aware of that. Can be more than one mode if there's a tie for the winner. Okay, so that's mean, median, mode, the basic stuff. Now that does get a little more complicated, and that's what we're going to talk about next, is some ways that they can kind of make it a little more complicated. So first off, let's look at a stem and leaf plot. Okay, stem and leaf plot, basically if I had these numbers 30, 31, 37, 45, 56, 57, 57, and 57. This is my data set. They can write it, and again, it's just a shortcut. Mathematicians are lazy, we like to save time. But what you can do is you can do 30, 31, and 37. All you do is write the single digits there next to that bar. So the number on the left is the tens place, so that's 30, 31, and 37. So 45, you just put a 5 here, and for the 56, 57, 57, and 57, you'd write it like that. Okay, one thing you'll always see stem and leaf plots in order. You'll never see them out of order. I suppose you could, but it'd be easy to just realize what's going on there. So we can still find the mean, median, and mode here. That's the whole point. The mean would be you add up all these numbers. Now remember, you're not going to see this here. You're just going to see this. So all you have to remember is that's a 30, a 31, a 37, a 45. You just add up all those numbers and then divide by how many. Well, this number, the number of numbers to the right of the bar tells you how many numbers n is, so what to divide by. So there's 3 here, there's 1 here, and there's 4 here. If you add all those up, that's 8 total. So there are 8 numbers in this data set. Okay, so n would be 8. So we'd add up all the numbers, blah, 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 plus blah, 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 all the way up, add up all 8, and then divide by 8 to find the mean. Okay, the next thing would be the mode. Mode is actually really, really easy here. See how there's 3 7s? That means 57 is our mode. It occurred 3 times. There's no other number that occurs more than 3 times. So mode is pretty easy. And the median, that's not too bad either. As long as they're in order, you start crossing off numbers, right? The biggest numbers and the smallest numbers till you get to the middle. You realize that 45 and 56 are your 2 middle numbers. So you add them together and divide by 2. You find the average, and that would tell you your median. Okay, so pretty straightforward. Let's look at another example of a way that they can sort of put a data set together in a sort of a table. This one's called a frequency table. All right, basically, if you have a huge list of numbers and you don't want to write them all out, right, there's got to be like a shortcut, okay? Maybe a number occurs a lot. So you could say something like, let's just look at an example here. All right, so here's the number that occurs in the data set, and here's what we call the frequency. It's how often it occurs. So if you had the number 50 occurring 13 times, you had the number 60 occurring 21 times. If 70 occurred 6 times and 80 occurred 15 times. So really what that means is our list is 50, 50, 50, 50, 50. There's 13 50s before we get to 60, 60, 60. There's 21 of those. So this is a huge long list, okay? So we can still find mean, median, and mode, right? The mean, you could add up 50 plus 50 plus 50 plus 50, but that takes too long. Really just use multiplication, right? 50 times 13. That's the sum of all those 50s. You add that to the sum of all the 60s. So 60 times 21 plus 70 times 6 plus 80 times 15. That right there would be the sum of those numbers. Okay, just use multiplication to make it a little easier. Now you do have to know what n is, right? The number of numbers. Well, that's just the total of this frequency column. If you added that up, you get 55. So we divide by 55, and that's going to give us our mean. Okay. The mode is pretty easy. Which of these numbers occurs the most? Well, that's pretty straightforward. 60 occurs the most. It happened 21 times. So 60 would be our mode. Now for median, you sort of do the same thing. You start crossing off numbers. What you do is you cross off 13 numbers here and cross off 13 numbers here. That leaves 2 numbers remaining. I'm just crossing off these numbers as I go. If I cross off 2 numbers from here and 2 numbers from here, that would leave 19. If I cross off 6 and 6, that leaves 13. So what that means is in the middle of this data set, 50, 50, 50, 50, I've got 13 60s in the middle. Okay, 13 60s in the middle, and then I've got more 60s, and then it starts to be 70s. So the middle is going to be one of these numbers here, 60. So just think of it like that. Another way is you can say, well, what if there were 3 numbers, right? What would the middle number be? If you had a number, the second number would be the middle. Could you calculate that using a formula? Sure. You take the number of numbers, n, you add 1, and you divide by 2. That will be your middle number. So it's kind of like a formula. Let's say you have 5 numbers. We know the third number is the middle. Well, n is equal to 5 here. So you do n plus 1 divided by 2. So n plus 1 is 6, divided by 2 is 3, which of course is our middle number. What if you had 1, 2, 3, 4, 5, 6 numbers? Well, you'd say n is equal to 6. Don't forget, your number would be the average of third and fourth. So we could call that the 3.5 number, right? The average of 3 and 4. So you just do 6, which is n, plus 1 divided by 2. That's 7/2, which is 3.5. If you get a decimal like 3.5, just remember to do the third and the fourth and average them together. So in other words, in that last problem, we could have done, oh, there's 55 total numbers. 55 plus 1 divided by 2, that's 56, divided by 2, that's 28. It means the 28th number in the data set would be the mean, or the median. So we know, okay, there's 13 here, there's 21 here, that's 34. That means that somewhere in the 60s was my median. So you can do it that way as well. Okay, all right, so moving on to the next idea. Okay, now we're going to start talking about counting. So the number of ways that you can do something. The number of ways to do something. Okay, this is a very common thing on the ACT. They ask you to count things. So the most common type of problem that you're going to see out there is one where it's like there's 3 choices for whatever. There's 2 choices for something else, and then there's 3 choices for something else. So it could be clothes, it's oftentimes food. Those are the main ones that they'll use. So maybe you're making a dessert, there's 3 choices for ice cream, 2 choices for a topping, and then there's 3 choices for, sprinkles, 3 different colors of sprinkles. So how many different ways could you assemble a dessert with ice cream, toppings, and sprinkles? Okay, so we're going to use what's called the multiplication property. All you got to do is multiply the numbers. So there's 3 choices for ice cream, 2 choices for toppings, and 3 colored sprinkles. Multiply them together, you get 18 different choices. Okay, that's really, really basic. Another way you can think about that is these like 3 blanks. Okay, how many choices do you have for the ice cream? Right, this is ice cream, this is toppings, and this is sprinkles. So we have 3 choices, so we fill in a 3 there. How many choices for toppings? There's 2. How many choices for sprinkles? There's 3. Multiply them together, you get 18. The reason I show it to you like this is because there'll be some examples in the future that I'll show you that are very similar to that. Okay? All right. So let's look at an example of that kind of problem. Okay. How many 3-letter words that don't repeat letters are there? Now, when I say words, we're going to call ABC a word, right? Even though it's not really a word, we're going to say words. So it doesn't really matter if it actually makes a legible word. But how many 3-letter words don't repeat letters? Okay, well, let's think about this. How many choices do I have for there's 3 letters, so I have 3 blanks I need to fill in. How many choices do I have for the first letter in the word? Well, there's 26 letters in the alphabet, so I have 26 choices. Now, if I'm not allowed to repeat letters, whatever letter I picked for that first choice, I don't get to use again. So that means that I have less choices now. I have 1 less choice. So that means there are 25 choices for the second letter. Now that I've chosen 2 letters, I can't use either of those for the third letter, which means there's 1 less choice. So I'm going to have 24 choices for the third letter. Now again, these are choices. I have 26 choices for the first letter, 25 choices for the second letter, 24 choices. And we already said that when we're counting, we multiply these numbers together, and that will give you the total number of 3-letter words that do not repeat letters. Okay, again, you just use your calculator to calculate that. All right, moving on. Next thing is what we call arrangements. So let's say arrangements are basically how many ways can you rearrange things? How many different ways, we'll say, can you arrange? Let's just call it, let's give it a number. Let's arrange n objects. Okay, so n could be any number. So let's say as an example, how many ways can 6 people line up for a ride at the carnival? Okay, how many different ways? Well, you could have person A, then person B, then person C, then person D, then person E, then person F, or it could be A, B, C, D, and then E and F switch, right? You can see that you could list all these out, but there's going to be a whole lot of these, so we don't want to do it that way. So one way is to use the kind of the counting principle that I just went over, right? So what I could do is I could make little spaces, like little spots, like spots that they're going to get into line. This is the person that's first in the ride. Here's the ride. All right, so this person's the first person in line, second, third, etc. So how many different people could there be in the first spot? Well, there's 6 people, so I have 6 choices, okay? Now, once somebody's in line, there's only 5 more people left. So I don't have 6 choices for the next spot. I only have 5. Okay, once there's the second person, now I only have 4 choices. You can see that it's going to go down, and then the last one I don't really get to choose much. Okay, so we're going to do 6 times 5 times 4 times 3 times 2 times 1. Now this is known as factorial. 6 factorial is what we describe as 6 times 5 times 4 times 3 times 2 times 1. Okay, so when you're talking about arranging a number of items, we see that n factorial is how you can arrange those items. Okay, so that's kind of the very basic thing about factorial. You have 6 people to choose from, and you have 6 places to put them. As long as those numbers are the same, you're going to just be doing an arrangement. We're saying, well, how many ways can I arrange these 6 things? Okay. All right. So oftentimes you're going to see factorial in different ways. Like maybe you see 6 plus 3 factorial. Don't forget just to do what's inside the parentheses first. So that's 9 factorial, which is 9 times 8 times 7 times 6 all the way down. Now, factorial is on your calculator. Okay, I could calculate 9 factorial. Go to 9 and then math. And I go over to probability, and you'll see down here number 4 has factorial. You don't want to do 9 times 8 times 7 times, it just takes too long, okay? You'll see that it's just faster to use the factorial button. So again, it's under math, over to probability, you go over to the right till you hit probability, and then number 4 is factorial, okay? All right, so that's the idea with factorial, where it's on in the calculator. All right, so moving on, how do we use factorial? All right, well, one of the big things that we use it is in permutations and combinations. So that's the next thing I'm going to talk about. Permutations. Okay, so in our last example, we had 6 people and 6 seats to put them in, or 6 places in line to put them in. Okay, when you have a different number of places to put the people that you have people, that's when you use permutations. Okay, when you have more things to choose from, or more people, more items to choose from, then you have spots to put them in. That's when we use it. All right, so how does factorial, or how does permutations work? There's actually a formula, okay? So let's look at an example, all right? What if we had 7 people, and I want them to finish first, second, and third in a race? Okay, you can see that there's 3 places for me to put them, first, second, and third, but I have 7 people to put them into these locations. That's when we use permutations versus just the arrangements where we use factorial. So first thing you have to know, okay, order matters. Okay, anytime you're using a permutation, order has to matter. What I mean is if it's John, Sally, and Phil, is that a different order, right? This is first, second, and third. Is that different than if Phil goes first and then it's John and Sally? Is it different? Yes, which tells me that the order matters. So that's how you know you use permutations, okay? Anytime order matters, whereas if you rearrange them, now it's something different, that's when you want to use permutations. All right, so let's look at the formula. The formula, we write NPR, okay? N is the number to choose from, right? It's our overall number. Like in our last example, we had 7 people to choose from. The N would have been 7. P just means permutation, and R is the number of spots to put them in. Put the people in, okay? So in our last example, we had 7 people. We had first, second, and third. So N is going to be the total number of people, and R is going to be the number of spots to put them in. So 7 choose 3, or 7 permutation 3, I should say. So N is 7, R is 3. So what we want to calculate is 7 permutations of 3. So the formula is this, okay? N factorial over the difference between N and R factorial. So in our case, it'd be 7 factorial over the difference between N and R. So N minus R, that's 4 factorial. So 7 factorial over 4 factorial. Now you can definitely use your calculator here, right? Make a fraction out of alpha y equals enter. Then do 7 math, number 4, divided by 4 math, number 4. And you get 210. So what that tells me, there's 210 ways that 7 people, okay, can be put into 3 positions, first, second, and third. All right. Now there is a way to do that on your calculator besides using the factorial button. If you go back to math over to probability, you see that there is an NPR button. So what it gives you these 2 little spots. So you just fill it in. 7 here, 3 here, and there's your 210. It's a little bit faster. Okay. Now, of course, you could do it by hand. 7 factorial is 7. We'll do that up here. 7 times 6 times 5 times 4 times 3 times 2 times 1. And 4 factorial is 4 times 3 times 2 times 1. All you got to do is cancel out the 4 with the 4, the 3s, the 2s, and the 1s, and it leaves you with 7 times 6 times 5, which if I get on my calculator, 7 times 6 times 5 is going to be 210. So that's kind of the way to do it by hand. But I think the calculator is just about as easy. Okay, so don't forget you can use your calculator and use it when order matters. Those are the 2 big things. So let's look at an example here. Okay, all right, how many choices for president, vice president are there from 12 candidates? All right, so president and vice president from 12 candidates. Well, we got to know N and we got to know R. All right, we got president, vice president. That means R is 2. How many people do we have to choose from? We have 12. So we want to do 12 permutation 2. Over to calculator. All right, math over to probability. That's what prob means. And number 2 is the permutation. So 12 permute 2, 132. There's 132 different possibilities from the 12 candidates to pick a president and a vice president. Okay, pretty straightforward. All right, so moving on to what we call combinations. It's very similar, except order doesn't matter this time. So when does order matter? When you're choosing president and vice president, the order matters. If you switch the 2 people, it's a totally different selection, okay? When does order not matter? Well, things like a committee, right? If you're on the committee, it doesn't matter if you were picked first or last, you're just on the committee. If you talk about a group, like a study group, Bill, Fred, and Sam Same thing as Sam, Fred, and Bill. Doesn't matter what order you pick the people in or what order you put them in. Just like a group. So that's when we're going to use combinations. Now, we notate it as NCR. That's the combination. N is the same thing as before. It's the total number to choose from. Okay, if we're selecting from 12 people, then N would be 12. R is still the number of spots to fill. Okay, it's the same thing as permutation. Now the formula is a little different. It's N factorial over the difference in N minus R factorial times R factorial. Okay, it has to do with the R factorial is the number of arrangements. So when you have, John, Sam, and Bill versus Sam, Bill, and John versus those same three people, but in different orders, we want to divide out those different possibilities for each of those choices. That's why we divide by R factorial. Okay, you can use your calculator on this. All right, if we go back to here, over to math, over to probability, you see that number 3 is NCR, and that's what we're going to use when we have problems like that. Okay, so let's look at an example. How many 6-person committees can be formed from 10 people? We'll just say groups. How many 6-person groups can be formed from 10 people? All right, all you got to know is what is N and what is R. N is 10, R is 6. Now remember, why don't we use permutations here? It's because order doesn't matter. The same 6 people, if you switch them, if they all switch seats, they're in the same group. Switch seats again, they're in the same group. So there's no need to put like individual seats. They just go as a group. So we're going to do 10, choose 6. Go to our calculator. Remember, go to math, over to probability, down to number 3. 10, choose 6. Gives you 210 ways to form a 6-person group from 10 people. Okay, remember we're just counting. That's what this whole chapter is about, counting. Okay, another example might be, what if you have, how many different 3-topping pizzas could you make? How many different 3-topping pizzas if there are 10 toppings to choose from? All right, would that be N or permutations? Which one of these are we going to use here? Well, does the order matter? If I put sausage down on the pizza and then I put green peppers and then I put mushrooms down, is that different than if I did it in a different order? No, it's going to be the same pizza. So order does not matter. So we're not going to use permutations. We're going to use combinations. So 10, choose 3, plug it in your calculator, you're done. So when you're doing these problems, one of the main things you have to know is, does order matter? That tells you whether you use P or C in the formula. Okay, so those are our big counting formulas. Now we're going to move on to something different. All right. All right, next thing we're going to talk about is when we count multiple events. Multiple events. So you've done this a million times. You may not have heard it called counting multiple events, but basically what I'm talking about is Venn diagrams. Okay, this is what's going to help you visualize this. Okay, so you've got your box, which we call the universal set, and then we've got 2 things. So maybe event 1 is A, and event B is right here. Okay, so if somebody is in here, what do you know? Well, we know event A happened, but event B didn't happen. Okay, what about right here? Well, event B happened, but event A did not happen. Right, if they're in the middle, we know that both event A and B happened for that person, and if they're out here, we know that neither of them happened. Okay, so first of all is some notation here. When you have something like A and B, okay, A and B, what does that look like? A and B has to be in the middle there. It's very tempting to try to color in the whole thing, but A and B is given by the overlapping. Like I liked A and I liked B, right? Maybe it's a food. I liked product A and I liked product B in this taste test. So that's just the sliver in the middle. Okay, if you say I liked A or B, well, what people in this survey liked A or B? Well, that would actually be the whole entire thing here. You either liked A or B, right? I think of it like, if I like pizza or French fries, if you bring me pizza, am I happy? Yeah, I'm happy you brought me pizza or French fries. I'm cool with either one. If you bring me fries, I'm happy. If you bring me pizza, I'm happy. If you bring me both, I'm still happy. Now, if I like pizza and French fries, it means I like them together at the same time. You bring me just pizza, I am not happy. That's why right here, we don't color in the whole thing, just a little piece in the middle. It has to be both when we're doing and. Okay, now if it says A, but not B, so I like pizza, but I don't like French fries. Well, where would that be? That would be this part of the picture. I like A, but not B. That's just this little piece right here. Okay, nothing in B. What if it's B, not A? Same thing. We're going to color in just the right side, but nothing in the common area. Okay, now here's another one, not A or B. So neither. I don't like either one. Well, we shade in basically the whole outside. Okay? All right, so those are the different things that they can ask you, the different wordings and what they represent in the picture. Now, I always recommend drawing a picture because it'll definitely help you out. Okay? All right, now let's go over one thing. We want to avoid duplicates. This is an issue that they kind of can trick you with on these kind of problems. Okay, duplicates. Let's call this event A and event B. So we use N of A to represent the number of people in A. Okay, now remember A is the entire circle here, including that overlap of B. Okay, so let's say that the number of events in A was 30. Okay, and let's say that the number of events in B was 40. The question is, what are the number of events in A or B? So that means put them all together. So I want to know how many are in the total. Most people are going to say 70. Okay, and that is incorrect. It could be correct, but most likely it's incorrect. And I'll show you why. Okay, if I color code this, it'll be easier to see. So the number of events in A were 30. So 30 people liked whatever A was. Okay, that's that whole region A. And then 40 people liked B. So that's this region here. Okay, and what happened is, look at this middle section. You see how it's green and red? I counted that area twice. So those are my duplicates. I counted the people that lived inside the little middle section twice. So when I get 70 as my total, it's incorrect. I overcounted by the number of people that were in the middle there. So what I want to do is subtract away that middle section. So what you end up doing is building this formula. Okay, the number of people that liked A plus the number of people that liked B minus the number of people that liked both. So that's A and B. That is going to be the actual number of people that liked A or B. Okay, and again, by that picture, basically what we're saying is the green section plus the red section minus the part that had green and red will equal the total. Okay, so this is what you use to avoid duplicates. All right, so just remember, if they say, you know, there's lots of ways that they can ask questions like this. And let's just, I guess, work an example. All right, so in a class of 32 students, all right, 15 liked pizza, 6 liked both pizza and fries, 2 liked neither. Those two crazy people. How many people liked fries? Okay, so first thing I would do is build a Venn diagram. Okay, so we get pizza and French fries. So here's the trick to this. Start in the middle and work your way outside. Okay, it says that 6 people liked pizza and fries. That means that there are 6 people in the middle. Then work your way out. Okay, the next thing it says is 15 liked pizza. Well, do I put a 15 right here? It's tempting, but no, that would mean that 21 people like pizza because we have 15 and 6. So you have to actually think, okay, I've already put in 6 people into that circle of P, so I only need 9 more to make 15 total. Okay, that's one of the biggest keys to this, is understanding that you start in the middle, and then if you've already put people in a circle, you don't need to add, you just need to add the number that would give you exactly what they tell you. Okay, it says 2 people like neither. So that means there's 2 people out here in the fringe. And then it says you that there's 32 students total. So how many students have I put inside this box? 9 and 6 is 15. 2, that means I've used 17. So if I take away 17, I get 15 more that I have to put in. So I'm going to put in 15 right here into the only French fries area. They don't like pizza. So the question is, how many people like fries? It's tempting to put 15, and they'll put that as a distracting answer on the test. But it's actually 21. Because if you think about it, this whole circle represents the number of people that like fries. There's 21 people that like fries. So just remember, start from the inside out, and don't be tricked by when they say 15 people like pizza. That does not mean that this number here needs to be 15. That means that number needs to be whatever adds to the middle number to make 15. Okay, those are the 2 ways they can try to trick you. All right, so moving on to the subject of probability. So probability is how likely something is to happen. And, you know, oftentimes we'll use percent, like there's a 50% chance it'll happen. That's a little different than probability. They're definitely related, but here's the difference. Probability, which we denote P of A, that's the probability of event A happening. All right, that probability of anything, probability has to be between 0 and 1. Like 100% and 0%, that would be the range of percents, but probability goes from 0 to 1. So 1, the probability is 1, it will happen. It's guaranteed. There's no way it won't. Okay, probability of 0 means that it will not happen. It is impossible for it to happen. If probability was 0.5 or a half, same thing, it means that it's equally likely to happen or not happen. It's like a 50-50% chance, okay? All right, so that's the basics about the numbers. One thing you have to know is that total probability equals 1. Which means if there's a 50% chance I'm going to win something, there's a 50% chance I'm going to lose. So in probability, what that means is, let's say there's a 1/3 chance of winning some kind of drawing. That means that there has to be a 2/3 chance of losing. Okay, those probabilities have to add up to 1. So the total probability adds up to 1. So basically, if you know the probability of something happening and you want to know what's the probability of something not happening, okay, the probability of something not happening, you just do 1 minus the probability of it happening. Just take it away from 1. So 1 minus 1/3, that's 2/3. That's where I get that from. The probability of something not happening is 1 minus the probability of it happening. Okay? All right. So let's think of probability in a different way. So probability can be thought of like counting. Okay? You can use those counting methods from earlier, right? Like those factorials and permutations and all those different things. You can use that counting methods to do probability. The way you want to think about it is the probability of something happening is the number of ways to do something very specific over the number of ways to do something very general. Okay? Easiest example would be there's an urn. It's got 2 red and 3 green balls in it. Okay, if I want to know the probability of drawing a red ball, well, the number of ways to draw a red, that's very specific, divided by the number of ways to just grab a ball. That's not specific. I'm not saying red or green, I'm just saying a ball. So how many ways could I grab a red ball? There's 2 different ways, right? I could grab the first red or the second red. How many ways could I grab a ball? Well, there's 5 balls. So we can think of that as 2/5 probability of grabbing a red ball. Okay, and thinking about it like this is a really, really good way to do it. It's the way probably most of you are taught, and it's the way that you should continue to be thinking about it. Okay, so let's look at an example. All right, what is the probability that out of a standard deck of cards, I grab a heart? Card that's a heart. Now you're gonna have to know a little bit about cards. There's 52 cards in a deck. There's 4 suits. Okay. You know, hearts, clubs, diamonds, and spades. There's 13 of each card in a suit. Each suit has 13 cards. There's black and there's red, and each of them have 26 each. Excuse me. Yeah, 26 each. Okay, there's 26 black, 26 red. Those are the basic things you got to know. So what is the probability of drawing a card that will be a heart from a standard deck? So remember, think of probability as something very specific. So the number of ways to grab a heart is very specific. There's 13 ways you could grab a heart, divided by the number of ways to just grab a card. Well, there's 52 cards, so there's 52 ways. So 13 52nds, which reduces to 1/4 would be your answer. Okay, so that's how you can think of probability as counting. Now, oftentimes we deal with multiple events when we're dealing with probability. So an example might be draw a green ball and then draw a blue ball. Okay, draw a green ball and then grab a red ball. That's called multiple events because you're doing 2 grabs. This does not sound like the same thing, but if it says, what are the probability of drawing 2 red balls? Okay, these sound different. Drawing a green ball, then a blue, or just drawing 2 at a time. Okay, when you hear draw 2 red, don't think of it as drawing 2 at a time. Think of it as drawing 1 and then drawing another time. So draw the first red and then draw the second red. That will help you make sense of this probability. Okay, so treat these 2 kind of things the same. One thing you got to know before we get started is what it means to replace, or using replacement versus not replacing, non-replacement. So replacing means you grab it, you look at it, you record it, and then you put it back in the pile. That's replacement. Not replacing means you pull it out and you leave it out. So when you do not replace, that will change your numbers. Meaning if you started with 52 cards, you pull out a card and you set it off to the side, now you don't have 52 cards anymore. Now you've got 51 cards. And if you drew a heart and put it down, now you don't have 13 hearts, you've only got 12 hearts. So anytime you're not replacing, or they'll say without replacement, that's the way they'll usually word it. When it's without replacement, it will change the numbers. So you've got to be aware each time you draw, the numbers are going to be different each time. Okay, so one way that they'll do multiple events is they'll use the word and. So the probability of doing something and something else. So I'm going to call this and that. So the probability of doing this and doing that. Okay, and always means multiply when we're dealing with probability. Multiply. Okay, you want to do this thing first, and then you want to do this thing second. So you're going to do 2 different things. All right. So the best way would be to just look at an example. So out of a jar that contains 3 blue candies, 5 green candies, 2 yellow candies, what's the probability of selecting a green and a blue candy? Okay, what's the probability of selecting a green and a blue? Well, this is this and this. I need a green and a blue. So first thing, you're going to do the probability of getting a green. Okay, what's the probability of getting a green? There's 5 greens out of how many total? 10 candies, so 5/10 or a half. Now be careful. Once I pull out the green, right, now there's less greens and less total candies. So when I calculate then grabbing a blue, now things have changed. There's only 9 total candies because now instead of 5 greens, there's 4 greens. And then there's only 9 total candies. So how many blues are there? There's 3. And then when I see and, I should always multiply. Okay, so a half times a third is going to be 1/6. And again, that's 15/90ths. And that reduces to 1/6. Real quick, just to make sure you know how to do this, if you had a fraction like 5/10 and you multiplied that by 3/9, and you, oops, that's dividing. All right, if you do it like this, 1/2, and you do times 1/3, you're gonna get this, okay? It'll give you a decimal. If you ever get a decimal and it's supposed to be a fraction, hit math, enter, enter. That will convert it into a fraction there, Okay, now if you use this trick of alpha y equals to build a fraction like this, I'm pretty sure it will actually go ahead and know that you're dealing with fractions, and it'll leave it as a fraction, which is kind of cool. It saves you that step. Now there's a couple steps to draw it out like that, but it'll go ahead and leave it as a fraction. It says, oh, you're using fractions, you'll want your answer as a fraction. Okay, so that's the basic idea between probability that is this and this. Okay, now remember, this is without replacement. Now they didn't mention it here, but if you're grabbing a green and a blue, you're not putting one of them back. So you have to assume that that's without replacement. If they say without replacement, of course you're going to do it. But when they say green and blue, you have to remember, oh, this is without replacement. Okay, I'm pulling it out. Now what if they said with replacement? 3 blue, 5 green, and 2 yellow candies. What if they said with replacement? Well, it's going to be a little different. You're still going to have 5 out of 10 for your first green. But then when you go get your blue, there's still 3 blues, but now there's still 10 because you put that other candy back in. So that changes things up a little bit. Okay, that's going to make 15/100ths, which is 3/20ths. So just be aware, this number changes if it's without replacement. If it's with replacement, if you put it back in there, that number won't change each time. Okay, and just to confirm, let's do one more. What if it said, what's the probability of grabbing 2 blues? Okay, and remember, this is a blue and then another blue. So and a blue, blue and blue. So the probability of blue, since there was 3, it's 3 out of 10. Remember, you do not put it back in, so now there's only 2 out of 9. That's how you would calculate it. So basically, it is 1/15. Okay. All right. All right, next thing we're going to talk about is this or that. So either or. So something like pick a green or a blue. Now, one thing we were just talking about multiple events. This kind of sounds like a multiple event, but this is not a multiple event. Okay? It's tempting to treat it that way because you see 2 different things, but it's not. It's just saying green or blue. Okay, so what you want to do, let's go back to that same exact last answer. We had 3 green, 3 blue, 5 green, 2 yellow. Okay, so what would be the probability of picking green or a blue? Well, green is 5/10, and blue is 3/10 probability. So think about this. If I say green or blue, I'm cool with either one. So that means I have a better chance now because I have 2 different options. So I have more to choose from. So how many total? Well, there's 8 green or blues. There's 8 candies that are green or blue. So really, it's going to be 8/10. Well, how did I get that? I add these 2 probabilities together. So when you hear or with probability, you should always remember to add them together. Okay. Also, or will happen when the 2 things cannot happen at the same time. Like you can't pick a green or a blue at the same time. If you draw one, it's either green or blue. So if they can't happen at the same time, that reminds you to add. If they could happen at the same time, like what's the probability of picking 2 blues? That happens at the same time. That's another reason when you multiply. Okay? So just think about it like this. If I say, blue and green at the same time, that's going to be harder because that's more specific, right? That's a more specific thing to get a green and a blue. All right, so that means the probability should be less. It should be harder to do. So you should have less probability. Well, when you're dealing with fractions between 0 and 1, to get less, you multiply the 2 things. Okay? When you're talking about blue or green, that's less specific. That's easier. Right? It's easier if you have more choices. Yeah, a much better chance. So that means the probability should be bigger. And bigger, the way to get bigger is to add 2 fractions that are less than 1. If you add them, that's what will happen. All right, so that same example, right, we had 5 green, 3 blue, and 2 yellow candies. What's the probability of green or blue or yellow? Green or blue or yellow. Well, green would be 5/10. Or means plus. Blue would be 3/10. Yellow would be 2/10. If you add those up, you get 10/10. You get probability 1. That means it's going to happen. Think about it. There's only green, blue, or yellow. So yeah, of course, if you say what's the probability of getting green, blue, or yellow from green, blue, or yellow, yeah, it's going to happen. One of them is going to be green, blue, or yellow, no matter what you pick. Okay? What's the probability of pulling a purple? How many ways can you pull a purple out of there? There's 0 ways out of 10 ways possible. That means the probability is 0. Cannot happen. So those are some strange ones that you might see. But they still kind of go off the same idea. Okay? All right, last thing is given. What is the probability of getting a green given you just drew a yellow? So you'll see this word given. Okay, so we had 5 green, 3 blue, 2 yellow. This sounds like it's multiple events as well, but it's not. We're just saying what's the probability of drawing a green. But you have to have already done this yellow bit. So what happens is you have to remember you pulled out a yellow earlier. Now, what's the probability of just getting a green? Well, there's 5 out of 9 ways to get a green. Okay? It's pretty simple. You just don't get tricked by the given part. You do have to do whatever the given was, you have to do it. So that's why I got rid of the 2 and I made it a 1. Because I already took a yellow out. Now, what's the probability of getting a green? Okay, so it's a single draw, but you've already kind of done a draw. So it's sort of like a double, but you don't calculate it like a double. We're not taking this and multiplying it by something. We just do one simple probability. Okay, now with probability, you can have these duplicates as well. And so what I'm going to do is remind you of that formula. So you want to avoid duplicates with probability, just like we did with Venn diagrams. Okay, so the formula will be a little different because we're not talking about the number of things in this Venn diagram. Instead, we're talking about probability. So it's the probability of A or B happening is the probability of A plus the probability of B minus that shared probability of A and B. Okay, so an example would be something like, what's the probability of drawing a jack or a diamond? Okay, so it's tempting to just do the probability of a jack plus the probability of a diamond. Probability of jack is 13 out of 52, or excuse me, 4 out of 52, and the probability of a diamond is 13 out of 52. So it's tempting to say, oh, it's just 17 out of 52, but that's wrong. The reason is because there are almost like this, right? There's 2 jacks, or there's 1 jack that is a diamond. There's 3 jacks that are not diamonds. And then there's 12 diamonds that are not jacks. So because we have this, if I just did this plus this, I would have counted this twice. That's why we subtract away the probability of the and part. So instead, what I want to do is take that 17/52 that I got here and subtract away the probability that's a jack and a diamond. Well, there's only 1 card that's a jack and a diamond, and so that will fix your probability. This is the correct answer. Of course, you want to reduce that to 4/13. Okay, so just remember, if the 2 things could be the same, like you could have a jack and a diamond, then you've got to do the subtraction. If it's not possible, then yeah, you just add the 2 probabilities together. But if there's this duplicate, this overlap, they're the same thing at the same time, you've got to subtract it away. Okay? All right, that's all I have for you today. Appreciate you being here, and we will see you next week.